Alright, so we created a very simple Cisco router in Honeypot. Um, so the best way to explain it is to look at the configuration. So we set up our defaults. This you need to do because if nothing is defined in the actual Honeypot implementation, which you need to describe below, that we can actually default to a default value for what we need to do with TCP, UDP, and RCMP packets that come in. So I created a Cisco personality. The nmap.print file actually shows you all the different uh, um, supported personalities of HoneyD. So I chose one that is potentially vulnerable. So I'm looking at Cisco routers, iOS version 12.2. From a vulnerability perspective, I'm actually looking at the entire 12.0 series of iOS versions, and potentially I can get some vulnerabilities detected in Nessus. So what I then did is I said, alright, so my Cisco personality, the default TCP action would be to reset. So if it's not open, reset the connection. So send a RST packet back as part of the TCP handshake. But then I want port 22 to be open. So port 22 SSH. I can most probably look at stuff like potentially like a heartbleed or some open SSH vulnerabilities that has been implemented in Cisco, and then Telnet. So the aim and purpose of Telnet is that Nessus actually does a banner grab, and based on the version, give me some potential vulnerabilities. That's part of the experiment that I'm doing. Uh, the other purpose behind opening up Telnet is that Nessus needs to do a brute force on um, my honeypot. So alternatively, I can use another tool to do a brute force attack. Um, the next reason is also to look for default usernames and passwords, and I basically want to record or record if potential attackers are using default creds, uh, if they want to determine if I use default creds in my configuration. Now the most important part when it comes to fooling a vulnerability scanner is not just the actual personality but the Ethernet MAC address. This needs to be legitimate, so you can reference IEEE. I do have some information on the wiki that tells you where to go look for MAC addresses, but there is a specific format that needs to be in these specific values. And because I'm working on my local LAN, I'm dependent on getting IP addresses from a highway router, so I'm implementing DHCP on Ethernet 0, so I'm physically actually plugged into my router. So that would be my configuration. I've already ran this experiment. What I would like to present is the actual findings, from a Nessus professional perspective. So the IP address I was given by my router was 192.168.1.9. I set up a specific policy around around the detection. It's not on this machine. It's actually on my machine I'm testing from. That's 192.168.1.4. So I exported the Nessus file. It's an XML file, and I uploaded it into my Ubuntu machine. So this is what Nessus came back with. So it said that port 22 was found to be open as well as port 23. So I had a very successful test on the script in terms of telling me or confirming that these ports are open. So that is not a false positive. That is that's reality. So very happy to see that the Nessus SYN scanner picked up this issue. Then in terms of the Ethernet card manufacturer, as I indicated, that's my MAC address. So I looked at the IEEE website to find a Cisco Systems type of MAC address, and funny enough, Nessus came back and said, no, this is definitely a Cisco Systems incorporated type of Ethernet card that I have here. So that is awesome, because I mean this would be the building blocks and the foundation for enumerating vulnerabilities or supposed vulnerabilities I have in my Honeypot. The last check, obviously then based on the operating system, I need to know that my personality is being reflected 100%. So the next check I had to do was OS identification. And the good news is that Nessus picked this up as iOS 12.0. It does have a confidence level of 65, which is not too high, but I'm happy about the result. I'm happy to see that Tenable actually picked it up as a Cisco iOS, and the method it actually used was SynFP. Right, just note that Nessus does use different types of checks to determine. So in the next few experiments, I will enable different ports. Maybe just to give you a highlight in terms of that configuration, let's look at my honeyconf. So I want to utilize NTP, port 500, port 4500, very popular on routers in general. Obviously Telnet because I want to capture usernames and passwords. Yeah. And then obviously just use the same Ethernet MAC address and then the same operating system personality. So that's what's to come, but good to see that Nessus is being fooled, by my honeypot.